Let's focus on learning objective 2.5a, and I'm going to show you how to algebraically find an exponential model. So let's look at this example here. The population of Mound in 2001 was 9,440 people, and in 2003 it was 9,431 people. They want us to write an exponential model for PT, or Y, basically, with T being our X, and T stands for the years after 2000. Now, if they had wanted us to find a linear model, we would just use y equals mx plus b, and from the data they gave us, we would find two ordered pairs and find the slope and what have you. But they don't want that, they want exponential. So we're going to use y equals ab to the x power. But we still need those two ordered pairs that would come from the data. Now, keeping in mind, they wanted t to be in years, and that's going to be our x value. So if I come up with two ordered pairs from this data that they've given us, and our x is our t value, and I need to have the years after 2000, for this first piece of data right here, t would be 1, and for this piece of data, t would be 3. So we have 1 and 3. And then the y value in this is the population. So we have in 2001, 9440, and in 2003, 9431. Now, the only approach we have is we know that these ordered pairs represent x and y's. But if you look at the function, we have an x and a y right here. So what we can do is write a system of two equations given this ordered pair and this ordered pair. I'm going to put 1 in for x and 9440 into y. In doing that, our first equation would look like this, with ab to the first power. And then our second equation would be 9431, and ab is going to be cubed. Now, to solve this system, what we want to do is we could do substitution. What I can do is actually take this equation right here and either solve for a or b, and then substitute it into the second equation. I'm going to take this first equation of 9440 a times b and actually solve it for a. So to solve for a, I'm going to divide by b. So it's going to look like a equals 9440 divided by b. I'm then just going to take that value for a, which came from the first equation, find a in the second equation, and substitute that in. When you substitute that in, what you're going to get is it'll be 9431 equals 9440 divided by b, all times by b cubed. Now remember, if we multiply this fraction and the b cubed together, it really just becomes multiply straight across. Now, property of exponents would say if we have a b down here and a b cubed down here, you can subtract. So it would be 3 minus 1, or you can imagine that you cross off this b down here and you're going to be left with 2 b's on the top. So if we do that, we're now going to have the 9431 equals the 9440 times b squared. Well, how would you take this equation and actually solve for the b? What you would do is to get b squared by itself, so I'm going to come on in and divide by the 9440 on both sides. When you do that, we're going to find that b squared is going to be equal to the value of 0.999. Now to solve for b, I'm going to come in and take the square root of that value and get that b is going to be equal to, it's going to be 0.9995. So now we actually take that b value and we can put it back into our standard format of the equation. So this value here will go into there. Then what we're going to have for our new latest equation here would be a y equals a times 0.9995 to the x power. Now the last thing we need to do is to find the a value. To find the a value, all we're going to do is take one of the existing ordered pairs. Why not take this one right here and put 1 in for x, and again the 9440 in for the y, and then we'll solve for a. When you do that, here's what you get. So to finish it off, to solve for A, I'm going to divide both sides by the 0.9995, and we're going to get that A is going to be equal to 9444.7. Okay, now we can take that A value and finish off the equation. We take that and we go and we put it in here. So our final equation is going to be y equals 9444.7 times 0.9995 to the x power. And that's our exponential model. Now the last step is they want us to predict the number of people that will be in Mound in 2020. Okay, keeping in mind, remember that t, or x in our equation, stands for the number of years after 2000. So in this case, we're going to put 20 in for x. If we do that, here's what we're going to get. So what I did is I put 20 in for x, I simplified with the exponents because that's first, then I multiplied, and we got 9,250.7 people. So the prediction is this is how many people will be in Mound in 2020.